Okay, we're back. This is basic statistics. We're looking at chapter 7. We're going to cover 7.1 and 7.2 in this video. So let's take a look. 7.1 is confidence intervals. And so what we're talking about with confidence intervals is we want to kind of capture the middle 95% or the middle 90%. It's usually a set percentage. So when we talk about page 1 on the note packet here, 7.1, 7.2, we're talking about unbiased. An unbiased estimator has an expected value equal to the population parameter. Consistent tends toward the population parameter as the sample size increases. Bigger sample size usually make it a little more consistent. And relative efficiency means we minimize variance. If we're talking very small variance with relatively efficient. All right. So let's take a look. They said, what are we talking about with a confidence interval? A 95% confidence interval. So 95% confidence interval actually is the middle 95%. If you remember your rules, the 68, 95, 99.7% rule was about, remember that was about, and it was 2 standard deviations above and 2 standard deviations below should capture the middle 95%. It's not exactly 2. If we look it up on our chart, so here's 95%, that's in between those two. It's pretty close to 2, but it isn't exactly. If we look it up on table F, and I will show you that, let me write down the numbers first. It's 1.960 and negative 1.960. So almost 2 standard deviations above and 2 standard deviations below captures the middle 95%. So let me explain something. If we were to look it up on the chart using it backwards, that would be a little tougher of a process. That would require us to think like this. We'd say, okay, well, we got the middle 95% here, which leaves 5% left over. So that's 2.5% there and 2.5% there. So if we're going to use it like backwards, our chart backwards, we wouldn't look up 95%. We would look up from there all the way down to nothing here. And so we would look up the 97.5% or 0.9750. We would look that up backwards. So let me show you what that looks like on the chart first. And then I'll show you the shortcut. There's a shortcut we get to take. All right? So here is the chart. If we looked up 0.9750, that would be right there. Here, let me see if you can make sure you can see it. 0.97. Okay, and if we follow that backwards, that is 1.96. All right, 0.9750. But the upside is we don't have to do that. There's an easier way for most of our problems that we have with confidence intervals. That is table F. That's on the next page. We look on the top, confidence intervals. If they ask for an 80% or a 90% or a 95% or a 98% or a 99%, we can just follow that all the way down to the bottom where it says Z. And so 95% all the way down to the bottom, 1.960 is the Z-score that goes with it. So much, much easier than reverse looking it up on the chart. And that's how the problems that you'll be tested on are going to definitely be on a confidence interval, like a common confidence interval. All right? Okay, so let's look at page 2. Notice the endpoints are cutoff Z-scores plus, okay, you get 2.5. Okay, so there's a little algebra here on how we set up an actual confidence interval. And so I can show you what that looks like really quickly. don't worry, you won't have to actually, like, you're not going to be tested on doing the algebra for this. It's just nice to know where some of these formulas come from, you know, and so this is what's going on here. Look, if we were looking at 95%, we'd say, okay, look, this is how we find z-scores. So remember last time, it wasn't just divided by sigma, it was x bar minus mean, the population mean divided by the standard deviation. But if there was a sample, we took that standard deviation and divided it by the square root of the sample size. So that's our new standard deviation. And so now we just use our sweet algebra skills. Let's get, what I want is I want just mu in the middle. This is what I'm after. So we got a lot of stuff to do. So first I would multiply everything by what it's being divided by. Sigma over the square root of n. So I take it times that, times that, times that. So now I got negative 1.96 sigma over the square root of n. Here, sigma square root of n cancel off. So we have x bar minus mu. And here we got 1.96 sigma over the square root of n. So we took that and multiplied it by each part of this inequality, compound inequality. All right, so now we want to get mu all by itself. That's the name of the game. So we'll subtract x bar from each one of them. So now we got negative x bar minus 1.96 sigma over the square root of n less than negative mu less than negative x bar plus 1.96 times sigma. All right. Almost done. We've got it all by itself, but it's a negative. So now we're going to multiply this whole thing by negative 1. That is, everything is going to get hit by a negative 1. So that means this is positive mu. These flip-flop around, so it's greater than sign and greater than sign instead of less than sign. Whenever we multiply or divide by a negative, we flip-flop the inequalities. That's now positive minus 1.6 sigma n, and that's negative negative, so now it's positive positive. And so here's the formula that we would use. We always put the less than on the left side and the greater than on the right side, so I'm just going to rewrite this over here. And I'm going to rewrite that over there. So for any 95% confidence interval, this is what we would use. We'd need population standard deviation, we'd need the sample size, and we'd need the mean of the sample. And we could do a 95% confidence interval for basically anything that gave us that. Also, just another little sidebar, this is called the margin of error. So if you watch any of the Three Stooges, hey Mo, Mo is one of the Three Stooges. And so Curly says that. Hey Mo. All right, so that's the margin of error. So once you find that, it's really the same there and there. It's the same number. So it's what you subtract from that and what you add to that. And that's the margin of error. All right, so let's do an example with some real numbers. So we're going to use this formula. Okay, and it says, so we're on page 2 on chapter 7. Suppose that in a sample of 50 adult males, mean height was 72. If a population has a standard deviation of 3 inches, find a 95% confidence interval. The height of an adult, males. Okay. So let's see. They got n is equal to 50. We've got mean is equal to 72. have standard deviation given as 3. So you just take 72. Oh, and they want 95% confidence interval. So that means we look up the chart, but we just did that. 1.960 is what the chart said. So we got 72 minus 1.96 times 3 over the square root of 50 is less than the mean, which is less than 72 plus 1.96 times 3 over the square root of 50. And so we do this is the margin of error. So the margin of error here is 0.832. So 72 minus 0.832 and 72 plus 0.832. And that ends up to be 71.168 is less than mean, which is less than 32. So really quickly, I'd like to explain what confidence intervals mean. So what this means, if we were to run this experiment, let's say 100 times. So if we're going to run this experiment 100 times, where we grab 50 random adults and we check their, take the mean of their heights, out of the 100, 95 of the 100 would actually capture the true mean of the population. 5 of them would not. So there's no guarantee that this isn't one of those 5. But there's, it's a better chance that it's actually captured the true mean than it didn't capture the true mean with a 95% confidence interval. But 95, so look, if this were the true mean and these intervals were graphed right next to it, the intervals would all be about the same size, but depending on where your mean was for that sample, see what happens is like this one didn't capture it. These did, this one didn't. And then we'll move it back. And so if we had 100 of them, these intervals would all line up. And so there's no guarantee this one isn't here, but there's also no guarantee this one isn't one of those. So when you say a 95% confidence interval, that's what you're talking about. It's if you replicated it 100 times, 95 of 100 would actually capture it. All right? Ooh, so this next one is pretty tough. On the top of page 3, and the reason it's tough, because that's not that bad. Don't get intimidated by, big, long, the formula sheet. These big, long formulas can be intimidating. Don't be intimidated. Just substitute them in, take it one step at a time, and you'll be fine. All right, so this one, though, is difficult because they ask for a weird thing. They want an 88% confidence interval for the mean 18-hole score for golfers if random sample of 35 golfers had a mean of 92 and a standard deviation of 5. So the tough part here is actually getting that z-score that we need, because 88 isn't on our chart. It isn't on table F. So we have to use the old gray matter here. 88% is there. That means 12% is missing. So that means 6% is here and 6% is there. So if we were going to look up that probability like backwards, using the chart backwards, we wouldn't look up 0.880. We would look up 0.9400. So this is what we want. And the reason we can't do it, let me show you, let me explain why this is a tougher problem, because they ask for a weird confidence interval, 88% they want. So look across the top here. There's 80%, there's 90%, so we could get close. 95, 98, and 99. There isn't an 88. So what we had to do is look up, but not 0.880. We're using table E backwards. We're looking up the probability and then finding the z-score that matches with it, but for 0.94, because you got to tack on that last little 6% that's over there. All right, so we look up the closest we have to 0.94 4, 0, 0 is 0, 6. Yeah, we'll use this one. Either one of those are just as close. 0.9394. We'll use that one. So if I'm using that, that's 1.55. And that's 1.56. I mean, if you wanted to split the difference and go 1.555, you could, but we don't need that kind of precision. We'll go 1.55. So there wasn't exactly 0.9400 for us to look up, but there was 0.9394, which is pretty close, you know, to 10 thousandths place, 6 10,000ths away. And so that coincides with z equals 1.55. So that's what I'm going to use for z. Oh, don't be confused also with the formula. They have it written like this. So they have x bar minus z, and they have alpha over 2. You really don't have to worry about the alpha over 2. That just means it's a confidence interval, like 2 tails. So that's just your z-score. So I'm often just use just z in my work. So I didn't want to confuse you. Don't worry about the alpha over 2 in the formula. If you want to put a little x on that, you can. All right. And remember, this is the margin of error. So this is x bar plus z times sigma over the square root. All right. Okay, so let's plop in our, now it's just plug and chug. So they told us x bar was 92. They told us we found z already, so we got that. They told us sigma, the standard deviation was 5 strokes. And they're looking at 35 golfers. So we're just going to sub all that stuff in. So we got 92 minus 1.55 times 5 over the square root of 35. It's less than mean, which is 92. And now this is a shortcut I do. Instead of rewriting all of that out, I'll just put margin of error. And now you put this in your calculator. You do 1.55 times 5 divided by second squared, that's the square root, 35, and then hit enter. And it gives you, it kicks out this. So 1.31 is our margin of error. All right. And so you add it and subtract it, and here we are. So 90, or an 88% confidence interval. It's such a weird confidence interval. Don't worry. I'm not going to give you a weirdo on the test or something. It'll just be a normal one that you can just use your chart without having to look it up backwards. All right. But I wanted to demonstrate one that isn't easy like that. So if you ever get out there and you don't have your chart, you know, you want a weird confidence interval, it can be found. All right. No matter what they ask for, you can find a confidence interval. Okay. So let's, again, flex our algebra muscles. We've got E, that's error, is equal to the z-score. They have alpha over 2. I'm going to omit the alpha over 2, just z, the square root of n. So now, if I had the error, but I wanted to know what n was, I can solve this. Let's, again, get our algebra. We multiply both sides by the square root of n. That cancels those off. So now I have e square roots of n equals z times sigma, and I'm trying to solve for n, so I divide both sides by e. So cancel, so the square root of n is equal to z sigma over e. And then I want to get rid of a square root sign. There's an equals, so I square both sides. Those cancel each other off, and n is equal to z times sigma divided by the error quantity squared. And that's how you can find an n. So on the bottom of this page 3, they said, okay, talking pizzas. Now we're talking my language, pizzas. Pizza shop owner wants to find a 95% confidence interval for the true mean cost of a large plain pizza. How large should the sample be if she wishes to be accurate to within 15 cents, so that's error. A previous study found the standard deviation to be 26 cents. All right. So first, we've got 95% confidence interval. So we're talking Z is equal to 1.960. That's on our chart. They gave us sigma. They gave us error, 1.5. And so now we're just going to take this and sub in that. So instead of Z, we're going to put 1.96. Instead of sigma, we're going to put 26 cents. And instead of E, we're going to put 0.15. And then we're going to square the result. So click that in your calculator, 1.96 times 0.26 divided by 0.15. Hit enter, you'll get 3.3973333. And then square that result. So with that in your calculator, just hit the little power key, the little caret key, and it'll say this. It'll say ANS, and then that, and then you just put a 2 there, and then hit enter. And then that way you don't have to type it in again. All right, so that's 11.54. Now even if this was 11.2, we would always take it up to the next whole sample. So if it was 11 point anything, you take it up to 12. So we would say, so she needs to sample 12 or more, and would have to be greater than or equal to 12 pizza pies in order to get a 95% confidence interval with only a margin of error of 15 cents. All right? Okay. Page 4, you can kind of skip. That's just, again, with Excel, I think Excel makes this harder. I think it makes it harder than just using the tables. So if you really want to use Excel, you go ahead and use Excel. And so then the next video I'll do will be 7.3 and 7.4 and 7.5. So that is it.